The construction of dam and other structures started with the construction of the diversion tunnel. The diversion tunnel of Mangdichu is 8.5 meters in diameter and 682 meters long. It's designed to cater for a monsoon discharge of 822 cubics, which is 1 in 25 years flood based on peak discharges in the monsoon season. Two gates of sizes 3.5 meters wide and 8 meters height for each opening have been provided to facilitate the closure of the tunnel and plugging of the tunnel before reservoir filling. Cofferdams are conventional rock-fill dam type, as the depth of the overburden in the riverbed at upstream cofferdam site is about 40 meters and the height of the cofferdam riverbed is 15 meters. The seepage through the cofferdam and the riverbed is likely to pose constructional problems. A positive cutoff up to the bedrock is required so as to keep the dam excavation pit relatively dry and carry out the excavation and concreting works below the riverbeds. The cutoff could be of the following types: the diaphragm wall or the jet grouted cutoff or the formation grouting alone. The permeability values varies from 9.4 into 10 raised to the power minus 3 to 1.1 into 10 raised to the power minus 3 centimeter per second in the overburden. These values are indicative of a relatively compact substratum. Since no clay bands have been encountered during the drilling, these compactness could be attributed to the presence of large boulders in the riverbed matrix. Keeping in view the logistic problems of diaphragm wall and the execution problems of jet grouting due to presence of large boulders, it was advised in the DPR to adopt permeation grouting. The DPR has also mentioned that the permeation grouting itself is not a 100% impervious barrier, and therefore, in addition to the normal dewatering, the well point dewatering system may also needed to be employed. To ensure a proper seepage control, it was decided to go for a foolproof measure, which is the concrete cutoff wall. The construction of the concrete cutoff wall under the upstream cofferdam is done in 3 stages. Initially, the pre-treatment works, then the excavation of the trenches, and then the concreting of the cutoff wall panels. The pre-treatment work is carried out to prevent the side walls from collapsing into the excavated trench, as the concrete for the cutoff wall need to be cast underground at greater depths up to 60 meters below the surface. Pre-treatment is done by drilling holes up to the bedrock level, both at the upstream and downstream face on either side of the center line of the cutoff wall. Holes are drilled at 2 meter center to center offset. The holes are then grouted with a mixture of lean cement plus bentonite and water for stabilization. There are a total of 109 holes that are drilled along the 110 meter length cutoff wall. Excavation of the trenches are done with the 2 main equipment: the trench cutter with a capacity to excavate up to 100 meters below the surface, and by the grab bucket, which has the capacity to excavate up to 80 meters below the surface. If the huge boulders are encountered during the excavation process, the boulders are broken down with the help of a huge chisel weighing 13.5 tons, dropped from certain height to produce impact like the hammer. As the cutter cuts into the material, the area is also stabilized by using bentonite suspension, which also helps to lubricate the cutting process. As the cutter excavates into the material, an excavated material along with the bentonite suspension is pumped to the descending unit. The descending unit segregates the excavated material from the bentonite suspension. The excavated material is dumped while the bentonite suspension is recycled and pumped to the bentonite tank farms. Bentonite tank farms are used to store the recycled bentonite and also to mix the fresh bentonite with water to be pumped to the excavated trench for stabilization of the trench. The trench cutter, which is the main equipment, excavates trenches to a dimension of 1.5 meter thick and 2.8 meters wide. 1.2 meter is the thickness of the concrete cut-off wall. Once the excavation of the trenches have reached the bedrock, the excavated trench is filled with plastic concrete. Plastic concrete is produced by a mixture of cement plus aggregates plus water plus high content of bentonite called pilogel. The water shall be led to the tunnels by an intake structure comprising of a RCC structure equipped with gates and trash rack and shall be placed adjacent to the spillway on the left bank. The intake has been positioned at almost 90 degrees to dam axis, which is advantageous for keeping the intake clean of silt during flushing operations. An inclined trash rack is provided for restricting the entry of debris into the tunnels. The structure shall also have grooves for stop locks, which are required for the maintenance of service gates. Mangdichu carries large amount of sediment. Two number Dufour type desilting chambers of 14 meters wide and 17.7 meter high and 340 meter long have been provided for exclusion of the sediment having a size of 0.2 mm and above. The targeted efficiency of the chambers is 90%. The chambers have been equipped with gates on the downstream end for isolation and maintenance. The accumulated silt shall be flushed out by an underlying silt flushing tunnel. The construction adits to numerous underground structures assist in providing access for construction of these structures. The construction adits include adit to gate operating chambers of desilting chamber, adit to gate operating chambers of the silt flushing tunnel, adit to desilting chambers, and adit to HRT. Some of these adits will be plugged later and those which led to the gate chambers will be used during the life of the project.
Dam is such a barrier. In our case, our dam is concrete gravity, which means the self-weight of the dam is supposed to contain the impoundment behind the dam. The excavation of the dam abutment is going on. On the right bank, we are about to reach the riverbed level. On the left bank, as per the schedule, we are supposed to complete by end of May. And with regard to the desilting basins, we just saw the wall concreting going on in desilting chamber number 1, and we saw the gantry erection for the crown concreting being done. So we hope to start the concreting of the crown by next month.
As per the construction schedule, the dam works are supposed to be completed by February 2017 to enable commissioning by September 2017. The progress of underground works at this point of time is ahead of schedule, and the slight delay in surface works is expected to be covered up during the concreting of the dam. The dam works were awarded to Jayaprakash Associates at the price of Niltam 5,969 million, and this has been now revised to 7,100 million, mainly on account of the cut-off wall. escape